Welcome, everybody, to another amazing episode of Wellness Warriors. I'm Dr. Veronique Desonier, better known as Dr. V, the breast cancer conqueror and co-founder of My Breast Friend. Today, we have another wonderful guest. I'm so excited. You're going to love this interview. His name is Dr. Barrie Tan, and he's hailed as the world's foremost expert on vitamin E, credited with discovering tocotrienol in three major natural sources, palm, rice, and annatto. He's a scientist first and foremost, and he earned his PhD in chemistry, biochemistry from the University of Otago in New Zealand. And his research focuses on lipid-soluble or fat-soluble nutrients that reduce and slow chronic conditions, right up our alley. So welcome, Dr. Tan. Thank you so much for being with us. I know you're a busy man, so thank you for your time.
And thank you for having me on, Dr. V.
All right, so let's talk basics here. We know that vitamin E has been talked about for many, many years as being beneficial and useful. But then lately, there's been a little twist on that thanks to your research and everything that you've done. So tell us a little bit about what exactly is a tocotrienol and how that relates to vitamin E.
Wow, well, thank you. This is a quick snapshot. Vitamin E was discovered in UC Berkeley almost 100 years ago in 1922. And some know and some do not know that vitamin E is sometimes dubbed as a birth vitamin because requiring this vitamin E would help the fetus to go to full term. Most of us may or may not know this, but most of us will know that vitamin E is an antioxidant. That we all know. And in the 1980s, many studies were done with vitamin E on tocopherol, the popular known ones, and most of it failed or didn't work, like that, and maybe do some harm. The lesser known vitamin E, which is called tocotrienol, I'll say one might a little mouthful of a word. The normal one is called tocopherol, which is found in the cereal box. And the other one is called tocotrienol, which is discovered halfway through of the 100 years, some 40, 50 years ago. This lesser known vitamin E called tocotrienol because it's kind of like a Johnny come lately. So it's also considered as an antioxidant, but mostly in the archive or published work didn't go any further. I started my career at University of Massachusetts in the early 1980s. And that was when I discovered this tocotrienol in palm oil. I did not discover the compound, but in palm oil. And through it, I stayed with it. I discovered it from palm. I discovered it from rice. And about 20 plus years ago, I went to South America looking for something else. And then I discovered it from this wonderful plant here. And the picture is also right behind me on the wall. That's annatto. This is a freshly if you look at it, it's beautiful. It's called annatto. We use the red color to color cheeses. If you look at the cheese, the yellowish orangey hue, that is from that. So this fruit have no flesh, just the seed. They have the carotene. And then another version of the beautiful plant. Only fresh one you can look like that. Otherwise, the wall one would be dried up like that. And it is truly from the Amazonia. And then people sometimes capture the imagination of Amazonia. It didn't. But Amazonia is also where we have the Amazonian tree frog. I'm very proud of this picture that I took when I was in Tampa. Look at it. That Amazonian tree frog is about smaller than the size of a penny. Just so you know. So Dr. V, because you are not very far away from Tampa, when you go to Tampa Botanical Garden, it's a small botanical garden, ask her where the annatto plant is. The British dubbed this plant as the lipstick plant because of the intense red color. And that's where I took this picture of the Amazonian tree frog. So it's truly from it. And one last picture, I know I don't want to distract you on it. In the Inca civilization, they used the marking on their body as a marking of the ranking in society. You can see that on the floor, what they're doing like that. So that's all to say, this is not a weird plant. It's a plant in commerce, in ancient civilization, all the way. So I was fortunate enough, almost spiritual as it were. I went to South America looking for something totally different. And I stumbled onto this plant. and then found out and have been arrested all my scientific career and have done this research for the last 35 years. And the most important of them all, which I know you will cover, will be on cancer, and particularly on women cancers like ovarian and breast cancer.
Wow. So why vitamin E? How did that capture your attention?
Oh, see, when I got this plant, the red color is something called carotene. We eat our colors, beta carotene, lycopene, like I show you from the picture. So those are carotene. But carotene in nature are incredibly unstable. Just think of the fall foliage in New England. For 2 weeks of brilliance, the colors show up, and 2 weeks after, everything turned brown. So they're not stable. They are stable in carrot and in tomato and in lobster is because they're bound inside the cell. In lobster, they're bound to protein. So the moment you cook them, they deproteinate, and then you see the astaxanthin color like that. Otherwise, they're unstable. So I realized that when I touch this seed, it stains the body. So I knew it's not bound to anything. There's a so I was just surmising it's got to be something very powerful that protected. I was thinking that it's probably some polyphenolics. Little did I know when I analyzed it, it is a vitamin E. And then when I studied further, it's a unique vitamin E, completely free of tocopherol and only contained the tocotrienol. From that moment on, I knew if this tocotrienol, since it's the most potent one, then I should persist in studying it in cell line study and then into animal study. And now I'm proud to say in the last 10 years or so, we conducted many clinical trials, not just only on the cancer. I know your audience is particularly interested, but we also study other chronic conditions like fatty liver, diabetes, and we're also studying with postmenopausal women with osteopenia. And then now we're having a study in Texas with postmenopausal women with obesity. So we're studying chronic condition. Cancer is the foremost important ones.
Right, right. So we know that inflammation is the foundation for all disease, right? Whether it's, cancer, diabetes, whatever. Now, so how does tocotrienol affect the inflammation? Is that a kind of a good starting point?
Yeah, that is good. That's an excellent starting point. I think of it simply, if you think of this as a cell, surrounding the cell is a cell wall, and the cell walls are fat. And if you look at the picture of a tocotrienol, this is not mean to be complicated. Here's an example of a tocotrienol molecule. Just look at it. It's got a head, and it's got an OH group here, which is an antioxidant where my fingers are here. Mm-hmm. And then it's a long tail.
Long tail.
This long tail here is saturated, is a very lipid soluble. The long tail is stuck in part of the biomembrane, and then the head sticking out. So this will capture gatekeeping. Anything free radical will tend to destroy the cell wall. This will block it. That's it. There are many antioxidants, Dr. V, but only certain antioxidants snuck in perfectly onto the cell wall, and this is one of them. And 90% of all the antioxidants in the cell wall, they are vitamin E molecule. They are CoQ10, they are lycopene, they are EGCG, all these, they don't snuck into the cell wall. This molecule does, and the tocotrienol is able to snuck in there 50 times more efficient than a tocopherol. So for that reason alone, it is important because all of us have about 38 trillion cells, about 5,000 times the population of the earth. So simplistically, it is a gatekeeper to protect our cells so that what goes in and come out is protected with cell integrity. Now, you mentioned, what about inflammation? Is that underwriting it? Yes. Today, I'm studying a lot about lung congestion. And it is very obvious why I'm studying that, because all of us are hunkering down because of this COVID. Whatever you say about coronavirus, SARS thing, everything end up with the phrase, something is agonizing the lung like mad. Otherwise, they would not need intubation and then would not need all this oxygen support. So we did study in 2015 and 2017 for asthma-induced condition and COPD, which is chronic obstructive pulmonary disease. We were doing that setup for non-communicable diseases. But whether it's non-communicable or communicable, it's the same thing. Because if you do it in such a way, here's the air sac. Think of all the grapes like that. If the air sac is compromised, there cannot be sufficient oxygen carbon dioxide exchange. And when we have inflammation like COVID, immediately we boost up a lot of immune system, and then the white blood cell called neutrophil will massively come to the sac. It is intended to kill the virus, a good thing. But the situation is so intense, so all these cells that surround the mass block the air sac from able to breathe, and therefore is congesting the lung. Tocotrienol is able to uncongest the air sac, uncongest the inflammation right on the epithelial, the skin lining of the lung. And then I thought, oh my God, tocotrienol can do that. We also study the mucous membrane. That is also a bad news, because if you have a lot of mucus in the lung, that cannot be a good thing. That is almost like you're drowning in your lung, even though you're not in water, inside your lung. So that's a kind of chronic condition. I know I don't want to take away all the time, and I missed the chance to cover the cancer thing, which is very important to you. So those are very inflammatory processes, and we directly saw the tocotrienol inhibit the inflammation, and thereby the breathing apparatus is a little bit significantly more relieved by 20 to 50%.
Wow, that's significant. That's amazing.
Thank you.
Now, let's talk about some of the anti-carcinogenic properties of this amazing molecule. Can you talk to us about that?
Yeah. First, I'd like to talk about how there are many ways to go after cancer. And I've read all the papers, not us doing the study, sometimes other people too. And it kills the cancer 3 ways that I believe the strongest. There are many proposals out there. I believe in 3 the strongest because they're repeatedly shown. One is that it just is able to directly go to the cancer cell and dial down the cancer cell and ask him to die. Basically, cancer cells have the DNA reconvene, or rework so that they immortalize. They just go on and on and on. So now the tocotrienol come in and ask and rework the DNA and ask him, you have to switch off now. So it inhibit, and scientists call this apoptosis. It make it to go to death. The second way is, as a cell is formed, they break into 2, 4, and then they become a tumor, and the tumor become bigger. So it inhibit by preventing the growth, inhibit and stifle the growth. The third one, I think the audience will capture it the easiest. When a tumor is much bigger than 1 to 2 millimeter, it's not really very big. By that time, it have to grow arteries into the normal artery to suck, because it couldn't have enough nutrient to suck nutrient to it. The growth of the new artery from the cancer tumor to the normal artery is called angiogenesis. Everybody knows this. So anti-angiogenesis is a way to come in to cut the blood vessel off. You essentially starve the tumor to death. Would you believe this? We actually have studied to show tocotrienol cut off the artery from the tumor. So therefore, tocotrienol is an anti-angiogenic agent. So those are the 3 proposals I best believe how tocotrienol can do. Now, after many cell line study, we call it test tube study, and many animal studies, we are now gone all in. Dr. V, we are all in. We have about 6 clinical trials done in Denmark. Some of them ongoing. And for the audience, if you want to look at the clinical trials, how it is designed, you go to clinicaltrials.gov. Again, I said clinical trials, plural.gov, and then you type tocotrienol clinical trials in cancer. You will see all of this, how much is done, what people they put on this. I'll give you a shorthand. We are conducting this on 4 cancers we know, all clinical trial: ovarian cancer, breast cancer, colon cancer, and lung cancer. Of course, the first 2 are only on women, and the last 2 include men as well. So now, since the ovarian cancer was the first to be done, so therefore the results are out. And I know I'm excited. I'm not pushing any. I spend my whole life doing this. If it isn't going to work, I like to tell my audience that I am proud to say that we have stage 4 cancer, stage 4. There are no available option. Stage 4 cancer on ovarian cancer. In that part of the body is not very operable. In fact, it's inoperable at stage 4. So we give them Avastin drug, anti-angiogenic drug, and then Avastin with tocotrienol. Those on Avastin drug, most of them do not live after 6 months because it's stage 4. Those on Avastin and tocotrienol, more than half of them, about half of them survive after 6 months. And even after 12 months, they continue to survive. Even after 24 months, 25% still surviving. So right now we're anxiously waiting for additional trial on the ovarian cancer, what that is up to. So the next study that will come due is in fact the breast cancer. I don't have the data, but I can only tell you my feeling. And remember, this is blinded. Therefore, I do not know until the study is all finished. But I did notice that in the study with the one, because they're blinded, but the consumption of those on the tocotrienol pill continue to go on. And the one that I have some pills remaining, which is the dummy pill, I do not have request to ask for more. So I can only intuitively say the ones that continue not to be asked of me, well, if the patient is diseased, then they're not taking the supplement. Are you with me on this?
Yes,
But
I get
if
it.
I've been asked to provide more and more of the supplement, so I don't know. I like to bear the good news. If you just hold tight, maybe interview me again in another year from now. I would, in fact, if I know if it's published, I'll be the first to send you that paper,
Yes,
and then you can release it. And the amount that these patients are taking is 300 milligram 3 times a day. Because it's lipid soluble, they take it with a meal, with breakfast, lunch, and dinner, 300 milligram, very straightforward. We believe, based on the separate study, not done by us, based on the pancreatic cancer study, the deadliest of all cancer, done in Tampa, Florida, I might add, at the University of Southern Florida, with one of my personal friends, Professor Malafa. He did it on pancreatic cancer patient. He feels that the optimal dose is somewhere between 500 to 600 milligram. That means 2 of those. But anyway, the clinical trials, we use 3. So the optimal dose may be 2. So unless a person is very, very sick to begin with 3, but once you load up phrase of 2 to 3 months, you can probably go down to 600 milligram for cancer patients. But for people who are normal folks, just for antioxidant protection, probably 300 milligram a day with a meal is just fine.
Okay. Now, have you done anything on prostate cancer?
I have not. I would like to do that. In fact, until I don't know the time will come if I will retire, I sure like to push for 2 more studies. Prostate cancer is one, and the other one would be liver cancer. Liver cancer because 80 million Americans have non-alcohol fatty liver disease related to diabetes. And by the way, they are also opportunistic for viral infection like hepatitis C. We are studying NAFLD and we find that it reduced the fatty deposit in the liver. We have done a 3-month study, double-blind study. We've done a 6-month study, and we're conducting a 12-month study. Can you imagine my tiny company? We are all in. Every little drop of money that we make, we're in to do this. So I'm really thrilled about it. So right now, I because of this COVID virus thing, I have thought of this, Dr. V. Virus come into our body to many organs, but virus particularly like 2 organs, the lung and the liver. In the liver, because many people have NAFLD, they opportunistically will get hepatitis C. Not a good thing. For the lung, many people are smokers or have COPD. So they opportunistically will get viruses such as the SARS viruses. So now we got the SARS viruses all over the map. And when we settle with it, we will not, hopefully, God willing, we will not have a pandemic, but still we will have endemic. They will have seasonal things coming in. So the concern for protecting the lung is not going to go away. But because the lung and the liver are most opportunistic to viruses, and these are also the 2 places with the maximum number of non-communicable problems. So they present themselves to the virus. So I know I carried away not talking about cancer. So I'm concerned. So I'm thinking of doing study a lung cancer, liver cancer, and then you add it on perhaps to balance the cancer part, to do prostate cancer, because they're estrogenic, androgenic for the men on prostate cancer, and estrogenic for the women on the breast cancer. Which is, by the way, that was the original reason why we study postmenopausal women with osteopenia, because that also is estrogenic. And we found that helpful. We found that it increased her osteoblast, the bone growing cell, and decreased her osteoclast during the postmenopausal period. So for that reason, too, a postmenopausal woman should be taking tocotrienol.
So what about a woman who has issues with fibrocystic breasts or polycystic ovarian syndrome? Where do you see the tocotrienols fitting in there as being helpful?
We have not done any clinical trials on that. In animal study, what we have found is that with PCOS, polycystic ovarian syndrome, is very inflammatory. Mm-hmm. When you give them tocotrienol, at least in animal study, we feel that it would suppress the inflammation purely because of its antioxidative protection. So that would be a reason that I would support that. And also many PCOS women are also prone to having diabetes. So there's that link to PCOS and diabetes. We only study the portion of diabetes and metabolic syndrome and fatty liver. So we didn't, there's so many areas I wish I have the ability to do. So we start
need
with
another 100 years, right?
I know. We start with the metabolic syndrome, diabetes, and NAFLD. So we went that direction, but we didn't go from the metabolic syndrome to the PCOS direction. But at least on the cancer side, we try to capture the largest cancer. And we believe that with the 2 that we didn't do, the other ones are pretty dominant types of cancer. So we're excited about that.
Now, somebody who is a stage 4 breast cancer patient and has fluid in the lungs, mets to the lungs, would that same dosage apply, the 300 milligrams 3 times a day?
I believe so, particularly when they're in stage 4, when their other options are not readily available. And if there is water in the lung, which is generally not a good thing as well. So minimally, that would suggest pulmonary inflammation. Mm-hmm. Usually, I thought of that as a pulmonary congestion. which they are the other side of the face, you know. So taking tocotrienol reduce the inflammation. In the study that we look at the antioxidant enzyme, it increased in the lung. And then also the oxidative compound, oxidative fat, oxidative protein, and oxidative DNA, they all drop in the lung of the animal. So all those suggest and point to me that it will reduce whatever damages it goes to the lung. So yes, I would definitely continue taking tocotrienol at the higher level dose. And if it subsides, the patient herself would probably know, and then they can drop down to 600 milligrams. Just always remember, don't take it in an empty stomach. Take it with meal, because with the emulsification and digestion, it will just absorb better.
Okay. And there's no, I know in the past, just talking about vitamin E in general, there was always the issue of, because it's a fat soluble vitamin, if you took too much, it would affect the liver. Now, have you found anything with, similar to that with the tocotrienols, or?
You mean on the safety issue?
Safety issue.
Yeah. Yes, we have. And in the study in Tampa, Florida, it was a surgical one. The professor gave people about 14 days out to a short period of time. And on the 14th day, they were coming under surgery. That's a very unusual study because they're pancreatic cancer. A patient with pancreatic cancer cannot wait. Otherwise, it will be lethal. So he cuts it. So therefore, the doctor is particularly concerned if there's a bleeding issue, and then the clot would not seal the wound. And he found that in the blindness, that compared to those taking and not taking, the wound healing, there is no difference. So that tells me that that's really, and that was published. Then the other one was an anecdotal study of one. It was published in Anesthesiology, Journal of Anesthesiology, of a girl taking tocotrienol and then go to surgery, and the wound continued to heal. No different than otherwise the anesthesiologists see any difference from people who are not taking it. So we know from that. Yeah, I think that would be, and that was taken in amount from the Tampa study was low dose of 200 all the way to as high dose as 3 grams. There's no clinical study asking for 3,000 milligrams, but he did that because the FDA want to know how high can you go before you see a toxic effect. He was expecting to see something at 3 grams. He did not see anything at 3 grams. But anyway, to the cancer part, he saw that it worked just fine, somewhere between about 600 milligrams. So,
Interesting. Okay. Now, you recently released a book, The Truth About Vitamin E, The Secret to Thriving with Tocotrienols. And you have generously offered for our listeners to get a free copy of the digital download of the book.
yeah, well, thank you. But it was a labor of love, Dr. V, because people ask me, can you simplify this in easy term, put in all the references if the audience wish to check. So I hunkered down for a year or so and put it out. And I decided that because this is my passion, I want it to be freely accessible to all. So if you go online, if you type in, visit Barrie is spelled BarrieTan.com, and then you type in the code with Dr. V, because it's from this show. The book would look like this. Did you see that?
Yeah, that's a younger, handsome you, huh?
So you will see me have it out. So if the audience want to have hard copy, we love to get, and we put all the references in the back. I went to how I did the discovery, have a few pictures in there, and cover all the area. And I have a generous portion on the cancer part. So this would be, and then if you have any question after you read, feel free to send us the thing. Our company is small. We're making this product in Massachusetts, and we are the only company in the US making this, and it's available in Canada. We have Health Canada. We also have it in United States all over, have been having this sold in the US for the past 15 years or so. Very confident, very comfortable with this. And we continue to map additional areas, mostly in chronic condition, simply because of the cell wall, because that everybody have cell wall. So if it protects there, it's almost like the door to your house. You know what house there is without a door. So if this is the gatekeeper, the door there, then everything is protected. It is needed in that way rather than something very particular only in the nucleus or only something like that. It's not quite like that. So it blocks it at the place where it normally supposed to do its work. So
wonderful, wonderful. Well, this has been so much fun. I could tell that you're very passionate about your work and still so excited after all these years. Thank you for all the research that you're doing to help, people that are struggling with cancer and other, diseases. And I'm sure that your work will continue to go on as a legacy long after you're no longer on this planet. So thank you, Dr. Tan. It's been wonderful.
Thank you, Dr. V, and thank you to your listener who listens. Hopefully you'll find good information from this.
Yes, we will. So thanks, Dr. Tan. Until next time, this is Dr. V sending you a big healing heart hug. Bye for now.